Alright, I finally finished number 2 from the homework. Have you gotten a chance to look at number 3 yet?
Yeah, I spent 2 hours working on it last night.
So how about we just switch problems and we can get it done so much faster?
That sounds like a great idea.
Perfect.
We just observed an example of cheating. While the students did some of the work, they also took a shortcut to avoid doing all of the problems on their own. As a result, half the work they turn in will not be theirs, which is considered copying. In doing this, the students rob themselves of the opportunity to work certain course problems which could prevent them from learning all of the material that could be on the exam. In the first video, we discussed the long-term implications of academic integrity violations. However, choosing to break the code of student conduct can also have immediate results on a student's academic career. If a student is found accountable of violating the code of conduct, there are several restrictions placed on the student. Examples include the inability to serve in various leadership roles within academic and social organizations, the loss of scholarships or work study, expulsion from ROTC programs, and removal from positions of responsibility, including residential assistants and research assistants. Students interested in medical school, law school, or other professional schools will have to report that they have been found guilty of violating the code of conduct, which can impact their chances of admittance. Ultimately, it's not worth the risk. Now that being said, we all know engineering is hard. Instructors know that students study together to help each other learn difficult concepts. In the next set of scenes, our goal is to highlight what is considered appropriate aid and distinguish this from examples of inappropriate aid. We are by no means saying not to talk to or help your friends. Instead, we offer suggestions on the best ways to do so. In these next few scenes, decide if the students are cheating or not.
Hey man, do you know what's happening in problem 4 of the calculus homework?
Sort of. I think I'm pretty close to it, but I'm not sure if what I have is right because there's one integral that was really complicated. So I think I'm going to rework it just to make sure I didn't make any mistakes at the beginning.
Do you mind if we do it together, just kind of step by step, just to make sure that we both, don't make any dumb mistakes?
Yeah, that'd be a great idea. I would hate to get it wrong after I put in all this time on it.
Okay, cool.
Cheating or not?
I really need some help. I have 2 tests tomorrow, not to mention a ton of homework and a paper. I also don't see how I'm gonna get all this done.
I'm really sorry to hear that. Were you at least able to get a head start on the calculus homework?
Luckily I was, last week after lecture, but I do have the service integral problem left, but I heard it was ridiculous.
Yeah, that was the toughest one. I had to go to the TA's office hours. Basically the whole class was in there today.
I wish I could have went, but I had an interview.
Sorry about that.
Wait, before you leave, can you help me get started on the problem?
Oh yeah, I have a meeting in 10 minutes though, so if you want to just take a picture of my work.
Oh, absolutely. Thank you.
Cheating or not?
Wow, that's a tough assignment. Probably the hardest one yet.
Yeah, you have to spend like 6 hours. How long did it take?
All afternoon. But I really understand the material now. How about you?
It only took me like an hour.
What? How'd you understand the material so? You have a tutor?
No, 2 guys in my fraternity actually took the class last semester and sent me all their old stuff.
Would you mind sending that to me?
Yeah, sure, dude. I can email it to you.
Thanks, man. It's gonna save me a lot of time.
Cheating or not? All of these instances are examples of cheating and would be considered a violation of the code of conduct. The students were told to complete an assignment independently, and they did not meet the expectations of the course instructor for independent work. Now, let's take a look at 2 approaches to help a classmate.
Hey, I'm having trouble with number 2 on the physics homework. Do you think you can help me?
Yeah, sure. This is how I did it right here. So for this problem, you have to first draw the free body diagram. You have to draw your gravity forces like this, your normal forces like this, and your tension forces like this.
Okay, yeah. Can you show me what you did next?
Yeah, then I wrote the equation like this. But you can basically copy it now since I basically showed you everything.
Yeah, I mean, I get it. So. Hey, I'm having trouble with number 2 on the physics homework. Do you think you can help me?
Sure, I can help you with that one. Do you remember from class how we did the free body diagrams?
I think I remember that we're supposed to draw a free body diagram first, and then include all our forces, which in this case would be gravity, tension, and normal force.
Yeah, that's right. Do you remember what comes next?
And then I think we use Newton's second law to relate all these forces, and then solve for acceleration using the net force.
Yep, that's the right approach.
Okay, cool. I understand it now.
In the first example, there was no real teaching. Just one student giving the other student the answer step by step, line by line. In the second example, we see a discussion about concepts, where the students talk about course concepts and suggest approaches to solve the problem, instead of just giving them the answer. This critical thinking will benefit both students. The next set of scenes expands upon this by addressing 3 examples of allowable aid. They are discussing the interpretation of the problem statement, sharing ideas or approaches for solving the problem, and explaining concepts involved in the problem. What does it mean to interpret the problem statement?
Can you have this chemistry problem? I don't understand it.
Yeah, so for this problem, we're trying to find the mass of required helium to fill this tank, given ideal gas behavior and the conditions presented in the problem.
Oh, so I can use the ideal gas law and solve for the number of moles and then solve for mass with the molecular weight.
Yeah, exactly.
How would you explain concepts involved in the problem?
Hey, so problem 5 on the homework asked about resistivity, but I didn't even understand it when we were in class. Do you mind explaining it to me?
Absolutely. Resistivity describes how easily electrical current can pass through certain metals, and it can be used to find resistance using the equation we learned in class.
Oh, okay, I remember now. I think the picture helps a lot. I think I can do the problem now.
Fantastic.
Let's see an example of sharing ideas or approaches to solve a problem.
Hey, so I remember talking about chemical equilibrium in class, but I don't remember how we were supposed to work through these problems. And there's a homework question about it. Can you help me?
Yeah, sure. Well, first of all, you want to write your chemical equation. Second, draw an ice table, and underneath it, you want to list your initial concentrations, changing in concentrations, and the ending concentrations. Third, solve for the ending concentrations using the equilibrium constant for the system.
Okay, I remember when we talked about that in class.
All these are acceptable and desirable ways to help your classmates. In each approach, the students get to brainstorm what the problem is asking, how they can solve it, and what key concepts and ideas are involved. This is the type of brainstorming that they'll be doing as practicing engineers, so it's a great start to their career to use these methods in their engineering courses. As we said, engineering is very hard. It's rare that engineering students can navigate the curriculum without a support network. The best analogy that we've seen is that engineering students are like fire ants during a flood. To survive, the ants all huddle together in a giant mass and rely on each other to help them ride out the storm. Your classmates are your support network, and we encourage you to use each other to all become better engineers. We just want to make sure that your help doesn't go over the line for what is allowed according to the Code of Student Conduct.